Hey everyone, my name is Evan. I'm the community manager at Tatum, and I'm joined here with Sam, the CTO at Tatum. And Tatum is a blockchain infrastructure provider and developer platform. So what we do is we provide you access to our infrastructure, and through our API, you can build blockchain apps really quickly and easily. So that's what this workshop is going to be about. We're going to show you how to build some apps really quickly on Harmony using Tatum. So we're going to go through the Tatum dashboard, how you sign up for Tatum. We're going to show you how to generate wallets, deposit addresses, private keys, NFTs, how to mint NFTs. And we might get into a couple other features along the way. Depends on where Sam goes with his presentation. So yeah, I guess I'll hand it over to Sam. And we're just going to start with how to sign up for Tatum using our dashboard.
Thanks, Evan. Hey guys, I'm Sam, CTO, co-founder of Tatum. I'm going to have this super quick workshop today. So first of all, if you want to work with our API platform, you need to sign up for dashboard and obtain API key from that. You can find the dashboard on our homepage. And once you sign in with your either Google or email, you will be able to generate API keys. Every user has three free API keys. You can create API key here. You just choose the free one and the mainnet or the testnet of the API key. I guess for the workshop you mostly leverage testnet, or it's up to you. So guys, you can obtain the API key for your generated API key, and you can see list of the API calls we support in our reference documentation, which can be available here. What we support is also we support client libraries, we support CLI, etc., etc. But I think the API doc right now is the best place for you. So there is a reference guide, and link to the API reference is available here. You can find all the Harmony endpoints we support in the specific section on the left side under blockchain / Harmony. Okay, right now there is a blockchain / Harmony, and you can find all available API calls here. We will start with the Web3 Driver, which is like the most common endpoint the native Web3 developers are using, and we can see that our API is running on the API eu1.tatum.io, and the API key is included in the URL. For all the integrations today, I'm going to use Postman, nice API tool for invoking API calls. So let's just invoke the Web3 driver. I have placed some parameters here. I have placed the URL, and I have placed the API key here. And let's just invoke the endpoint. This is a super simple one. Just get the information about the blockchain, if we are live or not. As a Web3 developer, you can leverage any Web3 call which is available. Feel free to use as you want. This API call is usually for, like, as I said, more mature Web3 developers, skilled one who knows what to do from the blockchain perspective. But we, on top of that, have some abstraction, which is unique in our platform, where you can easily generate wallets, perform transactions, or deploy NFTs or ERC20 tokens, etc., etc. Something which is not so simple. Something which requires Solidity development on your end. But if you don't want to leverage that, that's just fine. We have that covered for you. So first of all, let's start with generating a wallet. On our end, we understand wallet as a combination of mnemonic and extended public key. Mnemonic is top secret stuff you need to store on a safe place, and no one should be able to get access there. And from mnemonic, you can generate as much addresses and private keys as you want. On the other hand, XPub, or extended public key, is a read-only generator of addresses connected to this mnemonic. So if you want to generate wallet, you need to generate mnemonic and extended public key. From mnemonic, you will be able to generate private key, and you can generate up to 2 billion of private keys from one mnemonic. You just generate private key number 1, private key number 100, private key number 1 million, and all you need to store is one mnemonic from which you will generate those data. You have a private key, that's perfect, but you still don't have public address. The public address is the one you will display in your application. You will get to your users, please send my money here. So in order to generate address, we just need from you the extended public key. We don't need mnemonic at all. We just need a public key connected to the mnemonic, and again, index of the address you want to work with. So we can generate address 100, 1 million. This address for 1 million is connected to this private key for 1 million. Harmony is very Harmony supports 2 formats of addresses. The first format is the hex one, like Ethereum compatible one, and second one is a bech32 address, which has slightly different format than the hex one. Some applications leverages one format, some applications leverages Ethereum compatible. On our API, from our perspective, we accept parameters with both types of addresses, but we returns the values only in the hex format. So 0x is the beginning of every address you will receive from our end. But if you want to display addresses in the format of the one, there is endpoint to format address, and you enter the hex version of that address, and you will receive the one version of the same address. This is super fine and important if you want to leverage on a testnet some kind of faucet which accepts only one format and sends you free Harmony to play around. So this was like the first section where we covered like the most important stuff: generate wallet, generate account address from extended public key, transform the hex address to the bech32 address, and generate private key for a specific address. So these 4 API calls are the one which we covered right now, as well as the Web3 HTTP driver.
So I wanted to ask, and this is also from my own curiosity, what would developers have to do to generate wallets, private keys, and addresses if they were doing it from scratch as opposed to with Tatum? What would that entail?
They will have to install the Harmony client library, use the generate method, generate stuff, but they don't support these mnemonic-based addresses, just the pure combination of private key and address. So if they want to support 2 million of users, they need to generate 2 million of private keys and store 2 million of private keys on their end somewhere instead of one mnemonic.
Sure. So another thing that we have greatly simplified in Tatum is generating NFTs. And so you can currently generate them on 7 blockchains. We're adding more, and one of those is Harmony. The thing is, as I mentioned before, you don't need to code your own smart contract. We have already coded and audited and standardized an ERC 721 smart contract that can be deployed instantly. So instead of writing everything yourself and then making sure it works and then deploying it, you can just deploy it in one API call. So Sam, if you can show us how to do it.
Sure. Thanks, Ivan. As you said, we have a nice abstraction built for NFTs and ERC 721 standard. Now it works on 7 different blockchains, and Harmony is one of them. And I'm pretty sure you must all know what NFT is and what's the meaning in the crypto space, like for the last couple of months. But just to reiterate very quickly, NFT stands for non-fungible token. which is unique token, irreplaceable, one of a kind on the world. And it has a unique identifier and some kind of metadata which is connected to the token. And those metadata actually represents the physical stuff or the actual token, the actual unique thing which is represented on the blockchain with the NFT as such. So if you want to develop the smart contract by yourself in Solidity, you are free to go. You can do it by yourself a couple of weeks. You can test it. You can play around with all the tools necessary for like blockchain development. And at the end of the day, you will just end up with like almost a standard smart contract with no special features added on top of that. If you don't want to do that or don't have the capacity, you can leverage our pre-built smart contract, which is available open source on our GitHub, so everyone can see what's there, how it's written. We have forked the Open Zeppelin smart contract library, and we are leveraging those standards, but we have added some kind of our improvements, and the 7-to-1 is one of that improvement. So we are free to go. We can take a look at it. Everything is public. We never like make it private, so you know what you are working with. So enough of the talk. Let's just do the deployment. Let's mint one token, and let's see who owns that token and what are the token metadata. So basically, which URL is connected to the specific token. So what we need to do is we need to leverage NFT deploy endpoint where we choose which blockchain we will work with. Right now it's Harmony. We enter the name of the token to be deployed, symbol to be available, and the private key of the blockchain address from which the smart contract will be deployed. This private key will be then owner of the smart contract and will have the minting capabilities. So you will be able to mint new tokens only from this account. So let's just deploy one. We receive the ID of the transaction of the deployment, and we have again a handy endpoint to find the contract address of the deployment transaction. So we are working on one. This is the deploy transaction hash, and we read from that our NFT token is deployed on this contract address. The contract address for NFTs is very important because all the operations you will want to like perform, like minting, transferring, burning, will be connected to this address of the smart contract on the blockchain. So let's mint the new token. We have again prepared a nice abstraction endpoint for that, where you choose which blockchain you want to work with. We need to enter the address of the contract, identifier of the token, which is, as I said, unique integer, and you can never mint two tokens with same ID under one contract address. You need to enter the private key who can mint the token. So right now is the same private key as the one for deploying. We need to enter the recipient of the minted token, and we need to add some kind of metadata to this specific token. Let's say we will have our website where we will just show the tokens based on the ID. Very simple one. You can leverage IPFS as a decentralized file system. We also have integration for that. So you can leverage the IPFS URL here for the metadata. So let's just mint one. Again, the result is transaction ID. We can check the transaction on the Explorer on the Harmony. We are working with a testnet API key. So we are using the POPS1 Explorer from Harmony. And we can see the transaction was settled, and internally and in the logs, we can see that we have created token number 10, and this is the recipient of the token. We can find those data also from our API. We can just get harmonic transaction by ID. It's also available, but I'm not gonna look for it today.
Sure.
When we mint the token to the recipient, we can also check how much different NFTs a specific address owns for that specific smart contract. So, for example, I want to check for my smart contract how many tokens does 80D8 address owns, and we can see that he owns token number 10. Let's try to mint token 11, and I hope that he will own not only 10, but also 10 and 11. He now owns two tokens. So you can very easily display to your users in your application number of NFTs they own. If you want to, and so that's the first simple read operation, and another but important, even maybe more important than the list, is obtaining the metadata for a specific token. I know that I own token number 10, but I actually don't know what it represents internally. What are the data connected to that token? So another handy endpoint is to obtain metadata. We can, again, choose the chain, choose the contract address, and let's say we want to see metadata for token number 10. And we can see in the data as a result, this is the URL we have entered to the token during the mint phase. All of the API calls I have shown you were from the section blockchain NFT in our API doc. It was deploy, mint, get contract address, get account balance, and get metadata. So a couple of API calls, and you can basically do all of the operations with NFTs. What I didn't show you was the transfer, but the transfer is as simple as mint. We just use one as a blockchain. We need to add their correct contract address, and we need to add their correct private key. But I'm not sure if I have correct address for this recipient where I own token number 10. But the transfer endpoint is also very, very easy to leverage. Neviem, možno ten transfer vyhoď. Maybe get it out, Evan.
Okay.
Or I will do it one more time. I will need just to find the correct sender.
Mm-hmm.
Yeah, I don't have enough money there.
Okay.
I will do it like this. I will mint new token for transfer. Give me a sec. So I will mint token 100 to this guy. So let's mint token number 100 to recipient 0x. And once we mint it, we will be able to transfer it using this API call. Again, we need to enter the correct chain, correct token ID we want to transfer, contract address, new recipient, and now the private key should be the private key of the owner of the token. Right now, this address owns token number 100, so let's send it to someone else. And we can see it on the Explorer that we have sent the token from one recipient to another one. Okay, that's it for NFTs.
So another feature, if you are building any kind of custodial application on the blockchain, when you send any funds or tokens, NFTs, multi-tokens, anything from any of your users' addresses, you have to send funds to their address to pay for the gas fees to send things from their address. And sending those funds to them actually costs money too. So you're spending a lot of crypto and you're spending a lot of time just to be able to run any kind of custodial application. If any of you currently do this, you already know this, and anybody who's planning on doing it, you will have to do this. Except we've come up with a slightly different way of doing it, and we call it our custodial multi-wallet, and Sam will show you how that works.
Thanks, Evan. Not only that you will have to do it in order to cover the fees for your users, but imagine and that costs money. But if you will have, I don't know, 1 million of custodial users or hundreds of millions of custodial users, like, for example, Binance has, the amount of time you will spend in the back office of your application just to deal with this stuff, which address has money for operations, which address doesn't have money for the operation, and which should be funded and which should not. This is a huge problem, and more users you will have, the more problems you will have. So the solution I'm going to show you today is basically eliminating like 80 to 90% of this stuff, because you don't have to actually top up the address of your custodial user in order for transfer, for example, ERC20 tokens or NFTs from that custodial address if he doesn't have there the native currency, which is one in our example. So we have created a solution. It's based on a smart contract. So instead of just generating a plain address for your users, you will generate a new smart contract, which will be used for deposits for your custodial user. This smart contract is configurable. You can enable which tokens you want to support and which features you want to have enabled. And by default, it works with the native currency with one. And you can accept ERC20 tokens. You can accept 7-to-1s. You can accept 1155s. And the batch feature is also a nice feature, because in the future, when your users will deposit assets to their custodial wallet, you will have to withdraw the assets from that wallet. And if you will have, I don't know, different ERC20s or different types of NFTs on that address, and you want to perform multiple withdrawals from that custodial address, like by default, you would have to perform one blockchain transaction for withdrawing one specific token. When you enable the batch feature, you can, in one operation, enable withdrawal of any amount of assets to any amount of recipients. So you can basically swipe all the tokens you have on that address in one blockchain operation, which is again powerful. But on the other hand, what needs to be said, more features you will enable, more initial gas you will pay for initial deployment of that smart contract for your user. So again, it's up to you. You need to know which assets you will support, which not, and which does and which doesn't make sense to be enabled. So right now for this demo, let's just enable only ERC20s, the fungible tokens. Let's disable the semi-fungible, non-fungible, and disable the batch features. And again, we want to work with harmony with the private key of the deployer. This private key is the only one private key which you will need as a custodial provider from now, because from this private key, every transaction will be invoked. I mean, every deployment of every new custodial smart contract and every transfer from that custodial smart contract to someone else. So in theory, this is really the only one private key you need to remember on your end, and you will be able to operate on any of these addresses. So this is a huge, again, benefit for you, that everything could be on one end. All gas will be paid from this private key and from this account. So you need to just take care of having this blockchain address topped up with enough assets. So let's just deploy the contract. The result is just a simple transaction ID. Again, same principles applies as for NFTs. You need to get the address of the custodial wallet from this transaction. So this is the contract address you have deployed, and this address could be assigned to a user. So for example, to me, if I'm going to be user of your custodial wallet, for example, you will assign me this user, you will assign me this address, and I will deposit there my one. I will deposit there some stable coins as HRM20 token. I can deposit there some NFTs. I can deposit there some ERC1155s. Now I'm able to do everything on this address. So let's send some assets there. We have again a handy call to send one private key to the blockchain address. So let's just send there, for example, 0.091. We can check it on the Explorer, the address of the smart contract actually. So you can see the Explorer detected that this address, on our end, it's in the hex form, but here we can see the BEG32 version, that this address is a smart contract, but it has balance of 0.091 token. You can as well send there some HRC20 tokens. So for example, if you have some tethers or some stable coins, or you are issuing your own ERC20 token, you can send it there, the balance will be reflected. And if you want to withdraw assets from that address, you can use the endpoint transfer native asset. Again, you need to choose the correct chain you want to work with. You need to choose which type of asset you are withdrawing. The native asset is type 3. All these types are available in our API documentation. And this is the address of the custodial of the contract for the user. So you want to withdraw money from this custodial wallet. This is the recipient of the assets. And this should be the private key of the owner of the contract. So the private key which will sign the transaction will be the one used for deploying the address. So from this address, the gas fee will be paid, not from the custodial user balance. So let's just transfer 0.0006 to someone else, and let's check the transaction. I think we can also see it here in the Explorer already that we have withdrawn in this transaction 0.00061 to someone else. It's this operation. And you can see in the transaction that the transaction fee wasn't deducted from the address of the user, but it was deducted from you, from the owner of that custodial address. So, and in the internal transactions, you can see the transfer from that custodial user to someone else. So this is a huge improvement in terms of managing custodial wallets and being a custodial provider, because all the projects we are talking to are all the time asking, I'm a custodial provider, I want to cover fees for my users. How can I do that? Natively, from the blockchain perspective, you can't, but you can use some kind of nice smart contract logic, which can do that very, very easily. In the API documentation, this section about custodial stuff is included in the blockchain utils, and you can generate a custodial wallet. You can transfer assets from custodial wallet. And if you have enabled the batch feature, you can transfer multiple assets of different types in one operation.
So, Sam, I just wanted to ask, how much or what percentage of gas fees do you think this can potentially save custodial providers?
Mm-hmm. It's actually pretty simple calculation. You can calculate very easily what was the cost of deployment of one transaction. It's let's say 0.0031 for generating new address for one user. And if we take a look on the like regular transaction, transferring assets from one address to another, which we have done, we can take a look. It's, for example, this transaction. We have sent 0.091 tokens to that custodial address. But we can take a look what's the fee for that. So the fee for a regular transfer is 0.0002. So let's say in like how many? 15 transactions, like 15 top-up transactions will cover the initial cost for generating the custodial address. So you top up 15 times one address and perform 15 withdrawals to have the fees like same. You know what I mean?
Yeah, it pays itself off pretty quickly.
Yeah. After those 15 top-ups, you will be able to basically run for free, if we can say it like this. There will be like everything more, you will just earn the gas. Great. So yeah, the initial costs are a little bit higher, but you will save long term. You will save a huge amount of gas.
Sure. And it seems like a much simpler way to do it as well. And I mean, if you're dealing with millions of transactions and thousands or millions of users, it sounds like a complete game changer.
Yeah, that's definitely another point. It's not only the gas fees you will save, but if you calculate how much cost the back office will take you from the development perspective, because you need to pay developers to do that. You need to like run the back office, and it costs a lot of money just for powering up this type of application, actually.
Well, yeah, I mean, it sounds invaluable for fintech apps of all kinds. So if you're considering building a custodial exchange or a custodial wallet app or anything of that sort, this is definitely a much better way to approach it than the traditional way.
Sure.
Cool. Well, Sam, thanks a lot for digging into all of this with us, and I hope for all of you out there, this has given you a little bit of a glimpse into what Tatum's capable of. We just touched on a couple of API calls, but there's a wide range, a lot of stuff supported on Harmony, and it should be mentioned that the API is unified, so these calls work across lots of different blockchains. 30 so far, depending on what features you want. Different blockchains are different, but Harmony is a really great and fast and scalable blockchain for building fintech apps. So we definitely recommend, starting with it in Tatum with your apps. So thanks for joining us, Sam. Thanks again.
Thank you, man. Thank you, guys. Enjoy the workshop.
Yep. See you in the future.